Good morning, students. Welcome to Good Samaritan School online classes. Yesterday, we learned the physical properties of both metals and non-metals, and also, more importantly, the exceptional thing which is present in both metals and non-metals. That is given in page number 39 and 40. Right? And today, we are going to learn the chemical properties of metals. What are the chemical properties of metals? First, we start with what happens when metal react with oxygen, and what about a non-metal react with oxygen. We try to read or compare non-metal also along with metals, so that simultaneously you can find the differences between metals and non-metals, and what you can learn from both. Okay, so when we learn about metals, and it is easy for us to learn non-metals also. Okay, when metals react with oxygen, it gives basic oxides. When non-metals react with oxygen, it gives acidic oxide. And for this also we learned the activity in smaller classes. And I want you to remind you what we learned in lower classes. Okay, take an example of metal. For metal, I'm going to take an example of magnesium. Okay, magnesium ribbon. When magnesium ribbon is heated, that means react with oxygen, it gives magnesium oxide. Right? Remember this? So what we do, we take a magnesium ribbon and then try to rub that magnesium ribbon with a sandpaper and make the magnesium ribbon shine, and hold the magnesium ribbon with the holder, and then started heating it in a burner. What happened? That magnesium ribbon gives a dazzling light, a bright dazzling light, and after it burns completely, it gives the ash of magnesium oxide. And this magnesium oxide is basic in nature. You have to keep it in your mind. Whenever a metal react with oxygen, it gives metal oxide, and that metal oxide is always basic in nature. Understood? Okay, let me come back to this non-metal. When a non-metal like sulfur, what is heated, or in other words react with oxygen, it gives sulfur dioxide. Okay, take an example. I have taken a sulfur powder, a small amount of sulfur powder. In 9th standard we have seen sulfur powder. It is yellow in color, remember? And then I am going to heat it. When it is heated, it gives sulfur dioxide gas, and this gas is acidic in nature. How we know that it is acidic in nature, and how can we identify this magnesium oxide is basic in nature? What we did, remember, we took some water and mixed with that ash, and this will become magnesium hydroxide. And magnesium hydroxide is basic in nature. So what happens? This changes the red litmus to blue color. So it shows that basic in nature. And for this same SO2, sulfur dioxide, what we are going to do, same, mix with some water. Pass this gas in a gas jar and add some water and then shake it. So what happened? This gas is going to be easily mixed with the water, and it become H2SO3, and this is sulfurous acid. It is acidic in nature. So one thing you have to clear in this, what is that? That means when a metal react with oxygen, it give metal oxide, and that metal oxide is basic in nature. And when a non-metal react with oxygen, it gives again a non-metallic oxide, and that non-metallic oxide is acidic in nature. Okay, are you all listening now? Okay, now come back to this main thing. we are learning the chemical properties of metal. So we go and learn deeper on what happens actually when a metal reacts with oxygen. We have learned here, anyway, we are going to learn complete deeper knowledge on how a metal can react with oxygen. Basically, when a metal react with oxygen, it gives metal oxide. It gives a metal oxide. Let's learn what happens when it react with the highly reactive metal and then some medium reactive metal, and what happens when a low reactive metal react with oxygen. Okay, we see in the three bases. Let's see, this sodium is a very high reactive metal, not only sodium, and I want you to turn to page number 45 in your book, and you can see the reactivity series. In that you can see the table 3.2. there is a reactivity series of metals are given. In that, potassium is most reactive, then sodium, then calcium, magnesium, aluminum, zinc. So there is a reactivity series are there. If you watch carefully, most reactive metals are there, like potassium, sodium, calcium and all. And when you come back to magnesium, aluminum and all, they are little least reactive. When you come back to the last one, like a copper, mercury, silver and gold, they are even very less reactive metals. Okay, let's start with how they react with the oxygen. The most reactive elements like sodium, when it react with oxygen, it gives metal oxide. Sodium oxide is a metal oxide, right? It gives sodium oxide. And this sodium oxide is also a basic in nature. Okay, let's try with potassium. When potassium react with oxygen, what happens? It gives potassium oxide, right? So, and we need to balance this. So, put 2 here for oxygen and 4 for potassium. It's a simple one. Reaction of active metal we try to do with magnesium. We have already learned this. Again, we are going to do this. When magnesium react with oxygen, it gives magnesium oxide. And also you should balance all the equation. You have to balance. Magnesium react with oxygen, and that means we are just heating it. And this case, like an active metal, you need not to heat at all. You need not to heat at all, just a little bit. Just take an sodium and keep it outside. When it react with the oxygen in the atmosphere, they spontaneously burn. It burns just like that. Even potassium also, you need not to heat at all. Takes potassium metal and keep it outside. When it react with the oxygen, it burns. See, in this case, I am not heating at all. But when we come back to little lower, that means a medium reactive metal like magnesium, we are eating it. So magnesium, when it is heated, that means we are injecting oxygen. Okay, what happens when we magnesium ribbon keep it outside for a long time? Yes, it will become, you can see the magnesium ribbon, the color of magnesium ribbon fades. You can see rust forms on the top. That is why before taking using it for burning, I am rubbing that with the sandpaper, so that I am removing the rust which takes place on the top layer. So once it is burnt, it gives a magnesium oxide, and this is also basic in nature, and that is what we learned in the starting. Okay, now what happens when the very less active element react with oxygen? Take an example of a copper. Copper is the least reactive element, and when it react with oxygen, even the less reactive metal react with oxygen, it's slowly reactive. There is no high fast reaction. It takes very slow reaction even at an high temperature. So you can see an example of copper react with oxygen. It gives copper oxide, and this reaction is also a very slow reaction, but anyway it takes place and it forms a metal oxide. Even prolonged exposure of these metals to air and moisture makes the surface dull. That is why copper metal, if you keep on using the copper vessels at all, you can see a green coating comes on the top. right? Silver also, if you keep on using the silver and there is a coating of a black color comes on silver, that means prolonged using or exposure of these metals to air and moisture makes the surface dull. Okay, that's what happens here. Let's move on to the next thing, basic nature of metal oxide. If you see the basic nature of metal oxide, right, you can see this metal oxide react with the sulfuric acid, it gives salt and water. This is basically metal oxides will do. Okay, but not all metallic oxides. Some metallic oxides react with acids only, but some they react with base. But only few, that means only one or two can react with both. That means they have, as we know that when metallic oxide, they are basic in nature, right? They are basic in nature and they are not acidic in nature. But there are some metallic oxides which shows both acidic and basic nature. That kind of oxides which shows both acidic and basic nature is called amphoteric oxide. In the starting of the class we learned that when a metal react with oxygen it give only metallic oxide and that is basic in nature, not acidic, it is basic. Metallic always a metal oxide is basic. But here you can see some metallic oxides, some metal oxides which shows both acidic and basic nature. Here we are going to see some of the examples. Some examples are aluminum oxide and zinc oxide. So aluminum oxide and zinc oxide shows both acidic as well as basic nature. Let's see some example here. When aluminum oxide reacts with acid and base, you see what happens. Reaction will take place. See, when aluminum oxide react with hydrochloric acid, it gives a salt and water. And here this aluminum oxide is act as a basic in nature, because base react with acid, it gives salt and water. Clear? But here you can see this aluminum oxide, the same aluminum oxide can also react with base and gives sodium aluminate. It gives sodium aluminate and water. This is also a salt. It's formed here. It's given in your book also in page number 41. So I want you to just turn to your page number 41, which is given in your book, and also the definition of amphoteric oxide is given in that page itself, and I want you to write down in your copy, right? But only one examples are given, that means only for aluminum oxide is given in your book, but I am going to write for zinc oxide also. So see, this aluminum oxide react with both acids and base and they give salt and water. But here in the first case, when it react with acid, it is act as a basic. But when it react with base, it is going to act as a acidic in nature. Same, zinc oxide is also going to react with acid and also they are going to react with base. Let's see some example here. When zinc oxide react with hydrochloric acid, it gives salt. What salt is going to give? Yes, it gives zinc chloride and yes, water. And the rest of the things you are going to balance it. And how to balance that? Yes, just put 2 here, 2 here. So now it's going to be balanced. So when a zinc oxide react with acid, it gives salt and water. And here, what is the nature of this zinc oxide, which is react with acid? Yes, it is act as a basic in nature. Okay, let's see what happens when zinc oxide react with a base, NaOH. When it react with NaOH, that is a basic, it forms sodium zincate, Na2ZnO2 plus H2O. And you see what is the, you have to balance it before that going. Then now tell me, here this is a base And what is the nature of zinc oxide here? Yes, here it acts as a acidic in nature. Understood, all of you? Yeah, this is what an amphoteric oxide, but these two equations are not in your book. I want you to copy it from here and then use it for your further use. Right, student. So today what we learned, we are not going to learn more on this. Today we are going to learn only these things, and the next class we are going to learn on how a metallic oxide react with an water, and what are the different process which is takes place, anodizing and all. We will be learning on the next class. But today we are going to learn these things. I just want you recollect what we learned today. We started with chemical properties of metals. That means we are learning both metals and non-metals. What happens when they react with oxygen? Metal react with oxygen, it gives metallic oxide. Non-metallic metals react with oxygen, give non-metallic oxide. But the nature of these oxides are totally different. Basically, when a metal react with oxygen, it gives metal oxide. But here we learned how they can react with highly reactive metal, how they can react with medium reactive metal as well as less reactive metals. And then we learned the basic nature of metallic oxide, and some metallic oxide, they shows both acidic as well as basic natures. That is what we learned as amphoteric oxides. Okay, amphoteric, amphobian, it means they have both, right, acidic and as well as basic natures, and that is what we learned here. Clear, student? I hope you all understand this topic, today's topic, and go through this complete video, and if you have any doubt on these topics what we learned today, please try to ask me in my WhatsApp number. Thank you and have a nice day.